Second grade, we are back again, and I could not be more excited for our learning today. Arrays have been so much fun for these last couple of days. I know that you are ready to tackle this next step. The first day, we built with our tiles. The second day, we used pictures and drawings to draw our arrays. Today, we're going to step it up a notch and think about our equations mostly. You may find yourself, just like yesterday, some of you may have needed to draw or build that first time. You may draw on this first one first to get your juices flowing, okay? We want to make sure that you're making connections, what we already learned. So that's not a bad thing. I can't wait to see what you do to help you make sense of these problems. But we're really focusing on using those equations to really represent these arrays. We've got 2 problems to do together, and then you'll have an exit ticket to do on your own, and then some more practice for independent practice. Are you ready? Let's go ahead and look at our learning target. I can write an equation to express the sum of items in an array. That sounds really big, doesn't it? It's not as scary as it sounds. Let's break it down a little bit. Break it down. I can write an equation. Well, you already know how to do that. You've been doing that every day this week, right? We're writing a number sentence to match our columns and our rows. But then it says to express the sum. Really, that just means show the total, right? Show the total of items in the array. Again, you've already started doing that. We just had the helpers of visuals to help us the last couple of days, and today we're pulling those helpers away a little bit. So we're writing equations based off of these stories to show the total or the sum. Remember, the sum is the answer to an addition problem. So we're going to find that sum or the total of those items in the arrays that we can see. Okay? Again, this first problem you may find yourself drawing. In fact, I'll probably draw what we find on here and make that connection to the equation before we solve our next problem. So you may always start with that if you need to. Some students line up in 2 rows to play catch. Oh, we line up all the time in class, don't we? Each row has 8 students in it. How many students play catch? Write an equation to match the total number of students. Slow down, slow your roll. Let's read that one more time, and then you can go ahead and begin solving. Some students line up in 2 rows to play catch. Each row has 8 students. How many students play catch? Write an equation to match the total number of students. Now you may go ahead and solve. What clues in the problem help you know what you're going to add together? It says 2 rows of 8, so then where's that in your equation? Very nice. Is there another way you could add those together? I see your picture. How do you know how many there are altogether? Oh, I noticed that you didn't use an 8 in there. What did you do instead? You did groups of 2. And how did you count those? Okay. You didn't have any picture. You just wrote that equation. Tell me how you know. Oh, 8 and 8 is... And how do you know that's so in a snap? Very nice. All right, friends. Oh, my goodness. Hopefully the number 2 is a little more challenging for you. Are you getting this in a snap at home, too? Holy guacamole. All righty. I have some friends, and now I have friends that are doing all sorts of different things. But I do want to show you, where are my rows? How many rows do I have? Row 1 and row 2. And how many students do I have in each row? I have 8 students in each row. I'm assuming they're smiling because they're playing catch. 1, 2, 3, 4, 5, 6, 7, and 8. Very good. And what about my next row? Each row has 8, so I'm going to draw 8 more. And what do I know about an array? My rows have to be equal, And my columns have to be equal. Very good. So when I see that picture, what do you immediately write as your equation? Yes. Who else wrote that same thing? How did you know where the answer was going to be so quickly? That doubles fact, right? So we have our 8 and our 8, and our 8 plus 8 equals 16. But do you know that there's not just that one way to solve it? How did you solve it? One, two, three, four, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, the more add-ins I have, the more I need to attend to my precision, because I'm just going to be honest, sometimes I lose track. Okay? So, how I have 1, 2, 3, 4, 5, 6, 7, 8. Why do I have 8 sets of 8 twos? Why do I have 8 twos? I have 8 twos because there are 8 in each row, right? 2, 2, 2, 2, 2, 2, 2, 2. These are my what? They're my columns. Very good. And I have 8 groups of 2 or 8 columns of 2. And so that's where those are represented. Now, how did you find the total for that, friend? 2, 4, 6, 8, 10, 12, 14, 16. Can we skip count to help us find our total number in an array? We most certainly can. We skip counted yesterday. We skip counted the day before. We can easily skip count to help us find that total number. Very good work, friends. I love seeing, and I'm going to actually write that, 2, 4, 6, 8, I don't know what I was thinking, 10, 12, 14, 16. We want to see all of that on our public records. We can't forget what we're doing to help us make sense of this work. Now, I bet we don't even have to draw this picture the next time. What do you think? You guys were writing that in a snap. Let's read about Olga. I like that name, Olga. Olga draws an array of dots. The array has 3 columns. The first column has 4 dots. What equation can you use to find the total number of dots? Okay, 3 columns, and the first column has 4 dots. What equations could we write, or equation could you write to help you find that total? What are your clues in the story? 3 columns, and there's 4 in the first column. Okay, so if there's 4 in the first column, what do we know about all the other columns? Oh, and how do we know there's going to be 4 in those columns as well? Right, because an array has those equal columns. When you wrote that equation, what are you adding together? Are you adding the rows, or are you adding the columns? How do you know you're adding the columns? Because there's 4 in each, and how many columns are there total? 3 columns, so there's 4, or there's 3 of those numbers. Do you have a different answer, or a different equation? What are you representing in that? Your rows or your columns? Oh my goodness, friends, are you ready for this? Okay, let's go ahead and show some thinking here. So first of all, talk to me about what you said. So my friend over here, I'm just going to restate what they said. They said, I know that all the columns are going to have 4 dots in them. So if there's 3 of them, there's 4 in the first one, 4 in the second one, and 4 in the third one. And I said, well, how do you know there's going to be 4 in each? Because an array has an equal group, equal columns, right? 4 and 4 and 4. They all have to have the same number, right? So this represents our columns, right? There's column 1, column 2, and column 3. And my problem says what? That the array has 3 columns. Column 1, column 2, column 3. And the first one we know has 4. And if the first column has 4, then the other 2 will have 4 as well. But you didn't write that. What equation did you write? Okay, so you said 3 plus 3 plus 3 plus 3. What were you thinking when you wrote 3 plus 3 plus 3 plus 3? Okay, so if you are drawing an array and the first column has 4 dots, that means that there are 4 rows. And there are 4, if there's 4 rows, then the first row will have 3 in it. The second row will have 3 in it. The third row will have 3 in it. And the fourth row will have 3 in it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there's those dots. Oh gosh, I'm sorry. I didn't realize you couldn't see that very well. So in this array, if I'm writing an array to match this clue, then where are your 4 3s in your work? There's those 4 groups of 3. There's those 3 columns, 1, 2, 3, right? So when we go back and we think about this one, here's those dots, right? 3 columns, 4 in each column. I like to go back and draw it just to kind of double check and make sure that I know what I'm doing, right? So I've got my 3 columns, and there's 4 in each. And when you're adding, which ones are you adding together? You're adding that. So when we look at these 2 arrays, are these arrays any different? Oh, they both look exactly the same. But how are we writing an equation to help us solve them differently? One, we're focusing on the columns. One, we're focusing on the rows. What do you notice about the numbers from the story? 3 and 4. There's 3 4s. There's 4 3s. 2 rows, 8 students. 2 8s, 8 2s. Same thing from yesterday, right? 3 5s, 5 3s. We can use our story to help give us clues about how we're going to solve these, whether we're drawing a picture, whether we're building, or whether we're just writing an equation to match it. So, how many do I have altogether? How many dots did Olga draw? 4 and 4 is 8, 9, 10, 11, 12. Ooh. You know, sometimes when I have more add-ins, I get more confused, but why is yours a little bit easier to solve here? 3 and 3 is 6, 3 and 3 is 6, and 6 and 6 is 12. Friends, this thinking about arrays has been amazing. In fact, something that I want to make sure that I share with you, I don't want to forget, is this idea or this habit of looking at our structure or our patterns to help us make sense of problems. As we make sense of our math and think about new learning, we can look for those patterns in the structure to help us figure out how to solve these problems. And one of those important pieces is thinking about the array and how those numbers in the columns and the rows are connected to each other, and the patterns that we see over and over and over again when we're adding those columns together or adding those rows together. As you continue to make sense of these arrays and do more work with this, I want you to be continuing to look at those patterns and look at how these problems are set up to help you make sense of the arrays. Happy solving, my friends.